Well, good afternoon to everyone. It's after lunchtime, so it's always a little bit difficult to struggle and to be here on time. But let's do it. So the objective of this panel is to present 3 different case studies. And by the way, I present myself. My name is Gonçalo Simões. I'm the director of Biond. Biond is the Association of Forest Biobased Industries. So we represent Navigator, Altri, DS Smith and Renova here in Portugal. And I was invited to moderate this panel on sustainability. So the idea is to present these 3 case studies. The rules of the game is that each speaker is going to have 15 minutes to present. At the end of the first 10 minutes, I will tell more 5 minutes if needed. If not, we are going to have more time for the questions. So we are going to present Fátima Poças is going to present the first case study. Fátima has a master's in packaging from the Michigan State University. She's a PhD in biotechnology and presently a researcher and teacher of Biotechnology School of Catholic University of Portugal. I think you can go there, Fátima, already. So the first one is about food packaging, and I'm very proud to be here and to see that we have new case studies on food packaging, because for sure what the industry is today is not what the industry is going to be tomorrow. So innovation, new products are coming. And Fátima is going to present us a new solution on food packaging, which is a composite of PBAT and LIGNIN that has demonstrated excellent potential as a sustainable coating for food packaging. I mean, the main is more public affairs, communication, decision-making process, and I'm very happy to see, because in Brussels, each time we are going to Brussels and that we discuss PPWR, the recycling criteria, but also the eco-design, we are always talking about new products. And hopefully, because the researchers are doing this kind of job, that we are going to have these new products and new solutions to the sector. Fátima, the floor is yours.
Thank you, Mr. Chairman. Thank you. Good afternoon, everyone. Thank you very much to Tecnicelpa for the opportunity in showing, presenting this work. This work was mainly conducted by Francisco, my former student and colleague as a researcher from Católica, and Tomás Duarte from RAIZ. Francisco has recently moved into Finland, so is not able to be here today. So very difficult questions I need to direct to either Francisco or Tiago. So as the chairman already introduced, this work was done in under the scope of a PRR project, Fossil to Forest. So I will give a brief introduction and background, then the objectives and the approach that we follow it, very briefly materials and methods, and then the key results and conclusions. And as Mr. Chairman said, here the application regards food packaging. And I like very much to start showing this picture where we present, I borrow it from colleagues from Michigan State University. And in this picture, we plot packaging requirements regarding barrier to oxygen and barrier to moisture, along with the requirements from different foods, from foods very restrict to fruits and vegetables, for example, that are less strict. And we overlap in this map, we overlap what the different packaging materials can provide by those windows where we plot the different conventional materials from glass on the left lower corner and metals, for example, and then a range of plastics distributed all along, and bio-based materials, including cellulosic and some other biodegradable. And we conclude that the ability to extend food shelf life, which is a major requirement, using what is very common now with fossil-based plastics, is very difficult to replicate with bio-based materials, including paper. So we need high barrier papers, grease, oxygen, water vapor, and water. And we can plot also taking into consideration different applications from very short time of contact up to long time of contact. And we need to add on the barrier properties, we need to add the need for sealability if we want a food packaging, and to keep aroma barrier as well. So there, we all know that PFAS and other wet end additives were historically used to improve paper resistance, but now with phasing out due to different restrictions and reasons, other strategies are being discussed to improve the paper properties. From wet end non-PFAS sizing agents to fiber densification, including the use of micro and nanoscale cellulose. But our work is on coating with thermoplastics in order to achieve still a material that can be recycled and that shows improved properties. So we chose, under this context, we chose PBAT, synthetic biodegradable polyester, that currently relies on fossil-based resources in most of the material available in the market. However, new approaches that are already under development give us, and we know that it may be anticipated that very soon, if not already yet, in some cases, PBAT from bio-based sources become more readily available. So we trust that this polyester could be of interest to be used as a matrix to improve the paper barrier, to be used as a matrix of a coating. And then we have LIGNIN, which we have heard for in several talks during these wonderful days. It has properties, antioxidant, UV blocking, and antimicrobial properties, so it could be explored in this aspect to enhance oxygen and moisture resistance to be used in packaging components. However, the presence of hydrophilic groups limits the compatibility with polyesters. So we had to go forward esterification of LIGNIN for better compatibility with PBAT. So our objectives were to develop and characterize this bio-based composite coating using PBAT and esterified LIGNIN. We focus on optimizing the formulation and validating the performance, both at laboratory and pilot scale. That was done in RAIS. So our emphasis was this aspect of scalability and on the barrier properties, which are critical for food preservation. So the specific objectives were to evaluate the chemical and physical characteristics of the lignin esterified and its compatibility with the PBAT, to assess the barrier properties, the morphology, and the surface wettability of the coated papers, and to examine the feasibility of scaling the process through pilot extrusion coatings. So for the lignin esterification, we used methods already, or a method already described. We start with that based on propionic acid and acetone, and at a later stage, we introduced a catalyst, a small amount of sulfuric acid. For the incorporation of lignin in the PBAT matrix, so we worked in different directions. In lab scale, we used solvent casting after mixing the esterified lignin with the PBAT, a very common procedure that works at lab. But then for pilot extrusion coating, we had to prepare a master batch using a twin screw extruder to create this concentrated master batch of PBAT with the esterified lignin. And then on the coating machine, we diluted the PBAT master batch with neat PBAT in order to achieve a final content of 1% in the coating. And then we studied different pickup levels from 8 to 24 grams per square meter, and the substrate was a navigator paper. But we tried a different approach that was try to avoid the esterification step for the lignin by using a linosulfonate. So we know that this is formed naturally as a bioproduct during some pulping processes. And this sulfonated water-soluble lignin contains these aromatic and sulfonate groups which can act as compatibilization between lignin and the PBAT matrix. So this was a third approach that we follow. So these are the methods. What is usual to monitor esterification, the coating machinability, and then the applied performance. And starting with some results. So here we can see the infrared and nuclear resonance NMR techniques that we use to verify that the lignin esterification process was a success. And we can see here, I don't go into detail, but you can see the peaks corresponding to the proof that we have esters linkages in the product. Then we observed under SEM the different lignins. Here we can see the normal lignin. Here is the lignin esterified, and here we can see the linosulfonate, completely different aspect. And here the FTIR spectra also show the characteristics absorbent bands that allow us to compare the regular lignin with the linosulfonate. Then regarding the barrier properties, in the first graph we see the effect in water vapor transmission rate of increasing levels or decreasing levels, in this case, of incorporation of esterified lignin. And we see that indeed there is a remarkable reduction in the water vapor transmission rate when we incorporate very low levels, 1% of esterified lignin. the effect on the oxygen transmission rate was not so noticeable when we compare with the NEAT PBAT. But then here we compare the results obtained with the esterified lignin with the linosulfonates, and therefore avoiding the step of esterification. And we really see that with low levels, up to 5% of linosulfonates, can indeed assist on the compatibilization between the lignin and the PBAT with good results on the coating performance. Yeah. We also were concerned with what this mixture could do to the properties of the coating that need to be applied in a pilot, but in industrial conditions. So we see here the thermal properties. There was shifting in the crystallization temperature, but in terms of viscosity and the other parameters, the results maintain very good, and the rheological properties of the obtained coating could be adequate for the process. Then we actually produced the coat material using the pilot, and here we see the results for the different pickups for the water vapor transmission rate, and that's the blue line and the green line, and the different conditions of moisture and relative humidity. And the red line is for the oxygen transmission rate. And we were happy with the results. We understand that a minimal pickup of 24 is required to bring the water vapor transmission rate to the values, but the impact on the oxygen transmission rate is much more noticeable, even at low levels of coatings. And so, as a conclusion, so we verified that esterification was achieved. Also, it indeed enabled the compatibility between the lignin and the PBAT matrix. Low levels of esterified lignin worked better for the barrier properties. And the scaling up was possible, although we know that we need some fine-tuning on the operational parameters to make the coating more regular. And also the linosulfonates we consider as very promising as compatibilizers between the lignin and the polyesters at very low levels of concentration, and therefore avoiding the need for esterification processes. So the work is not completed, because now we are running tests of migration to see how the material interacts with food. And our colleagues from UBI are running recyclability tests for this coated material to see what is the effect on the recyclability of the paper once we have this modified polyester layer. Thank you very much for your attention, and our thanks to the Fossil to Forest.
Thank you very much, Fátima, for respecting the time schedule, because I remember that we are going to have then a roundtable with the CEOs, and we need to stick to our time schedule. So, secondly, Ana Quintela, which is a PhD in geosciences, a manager of silviculture and environment projects at REIS, the research institute from Navigator, is going to present us a case study about byproducts. And I need to be honest and to say, Anna, that I really prefer the semantic that you use in your abstract rather than the title, because in the title you use residues. on the abstract use byproducts. And in terms of communication, it's a big, big difference, okay? So help us and we help you. So Annie's going to present us a case study about byproducts from pulp and paper mills contributing to plant growth and soil fertility. Very specific, two types of end products were achieved. Number one, a soil alkaline amendment, and number two, an organomineral fertilizer. So the floor is yours, Anna. Thank you.
Boa tarde. Good afternoon. Thank you very much for this opportunity and also for the introduction. This is a great pleasure to me to be here presenting a work that is an ongoing work on a project that is from Agenda Transform about the circular economy, focusing the valorization of residues from pulp and paper mills. It seems we have here a few entities involved. But we have a large number of colleagues that contribute to the work. We have members from RAIZ, also from forestry and environmental and circularity departments of the Navigator Company, from Instituto Superior de Agronomia, and we count also with the contribution of Professor Mário de Carvalho. For all of them, thanks in advance for the collaboration and for the kindness. So let's take a brief look to the motivation of the project, its framework and activities that were involved. Let's take a step to what led us to the formulations and the end products, and also let's take a look into the tests that we run, trying to seek the feasibility of these products, not neglecting the safety, environmental values of the end products. So what motivated us to add value to the products of the paper and pulp industry? We know that these materials may largely be reintroduced or used in the process, but others still remain and represents expensive management, whether by external recovery or at last resource as a discard landfill. As for agroforestry, some of these materials have very interesting characteristics, and they are usually studied for as fertilizer or a soil amendment. And in this line, lime mud and the ashes for their content in calcium, and also the biological sludge for the content in organic matter, with another cocktail of micro and macronutrients that we know that these materials have, are very interesting, and that's why we look specifically to these type of materials. So what we thought about the project? So we start to thinking what are the characteristics of these materials and what are the compositional effect that we want to produce for soil improvement and plant nutrition. With these two informations, we gather the ideas and try to figure out what mixture could give the end products the desirable conditions that we want to provide. After that, we had a formulation and optimization stage for the production of these products, and then we passed to the field, to the 11 greenhouse trials under controlled conditions, and after field and semi-operational tests. So let's take a step forward. We achieved two types of products. One that is a soil alkaline amendment, a substitute for the commercial limestone, and another one that is a nitrogen-enriched organomineral that is a substitute to the synthetic commercial nitrogen fertilizer. Analyzing the regulation, which is not an easy task, by the way, we found that our soil alkaline amendment is not included or considered in the regulation that exists. So we have to undergo field trials to assess the feasibility of this product at the minimum monitoring stage of 3 years. And after that, we have to ask for the amendment of the ordinance, and after we may be able to advance to the registration. In what regards the nitrogen-enriched organomineral, fulfilling what is already in the ordinance, we can pass directly to the registration of the product. So here you can have the final purposes and the main composition of the two products. One alkaline amendment that is specially formulated to raise the pH of acidic or very acidic soils, contributing to good crop stand development. And another one that is the organomineral fertilizer that is enriched in nitrogen and organic matter, ensuring balanced plant nutrition and prolonged fertilization effect. A brief look to the main results. In our leaching tests, we found that potential hazard elements levels were all below the detection limit, even when we double the recommended doses for the products. We also performed some incubation with soils, and we collect and sampling 8 different types of Portuguese soils with different texture, ranging from sandy to clay texture, and different organic content matter. And we put the incubation ongoing with increasing doses of the products. We test 4 different types of soils for the alkaline amendment and 2 types of soil for the organic mineral fertilizer. For both, we observed that it was a positive response for both products with the different soil tested in comparison with their commercial reference. We are talking about limestone or urea. We don't have enough time to explore all the results, so here only an illustration about the results that we achieved with the alkaline amendment. What you have in the graph is the evolution curve of pH with 4 different soils at the recommended dose. Okay, so in solid line you have the response of our product, alkaline amendment, and in dashed line you can see the response of the reference. As you may see, the responses are very similar, and the alkaline amendment was effective in raising the pH from acidic soils. We also performed seed germination tests with a bioindicator plant, Nepeta cataria, and we found no phytotoxicity effects, even with the double dose of the recommended doses of each product. Here you have the results for each of the products. You have in black circles the number of seeds that were germinated, and in bar the growth. The gray bar represents the treatment with nothing applied to the soil. With the blue dark bars, you can see the reference response, and blue light, you have the response of our products, the recommended dose and even the double dose. So what we saw, it was that after 10 weeks after sowing, we saw a positive response in the number of seeds germinated with the end products. We know that we have different response, but that was accordingly to the type of soil also. But generally, applying twice the recommended dose, we didn't saw any phytotoxicity, and the growth was similar between the end product and the reference. Also for pot testing with subterranean clover, eucalypt and lettuce, positive response. And this viability of these alternative products move us quickly to the field trials and semi-operational tests, particularly with the alkaline amendment for the regulation obligations. This was a first test that was very important to us because it represents an added value for the end products that we developed in comparison with the reference. That is the possibility of applying mechanically the product without being so powdery. That's the real problem of the commercial limestone. It was also possible to achieve that the pellet kept their integrity even when bagged and transported. So this was very interesting and important to us, and we pass already to the field trials. In these field trials that we installed in last year, we considered different crops: strawberry tree, cork oak, eucalypt, biodiverse pasture, olive tree, and we considered also different treatments. Nothing applied to the soil, commercial reference at recommended dose according to the specifications of the soil, pH, and 3 doses of our end product. 1 dose that is half of the recommended dose, and double the recommended dose. Here's some illustration about our happy field days in the establishment of the trials. We installed 1 trial in the north, Valongo, and another in the inland, Penamacor, trying to seek different conditions of soil and climate. And we are collecting a lot of information from the field. Right now, we have already some results about soil pH after 6 months after sowing, and we have positive response in the raising of pH. But what is really enlightening is the response of the first cycle, vegetative cycle of pasture that you can see in this different image. And I invited you to try to figure out to which treatment each image belongs to. Every single of these pictures and this image refers to a treatment in the field. In all of them, a biodiverse pasture was sowing, okay? So, with nothing applied to the soil, what we saw is that we have a low production, less biodiverse, and with a low nutritional content. Instead, with limestone, we saw that it was an increasing in biodiversity and the filling of the soil, but it was actually with the alkaline amendment that we saw more production, more biodiverse pasture, and also with larger amount of nitrogen-fixing plants, such as clovers, Persian and subterranean, for example, which has a higher protein content and gives this pasture more interest for animal feeding. So what's next? We are going to monitoring the field trials, trying to reach the registration of these end products. We are going to make the final analysis of the composition and the final elaboration of the datasets. And also, we are going to perform a critical analysis about the technical, economical feasibility of the process and the products. So this project will end in the mid-2026. So we are still working on the final version of the video, but I would like to leave you with a small appetizer that I apologize in advance because it is still in Portuguese.
ProValor, a investigação que transforma resíduos em recursos, promovendo a economia circular. E se os resíduos da indústria pudessem ser reaproveitados para cuidar do solo? Com o ProValor, esta ideia começa a ganhar forma. ProValor é um projeto que procura desenvolver fertilizante organomineral e corretivo alcalinizante, formulados com resíduos resultantes do processo de produção de pasta e papel. Liderado pelo Raiz e pela Navigator Company em parceria com o ISA, este projeto junta ciência, indústria e ambiente para valorizar e reutilizar resíduos, promovendo a economia circular. Já foram criadas misturas com valor acrescentado e o primeiro esboço das respectivas fichas técnicas. Os produtos foram produzidos em quantidade necessária para testes de eficácia agroflorestal. E começaram a ser ensaiados em estufa, em condições controladas e depois em campo. Testámos a aplicação mecânica em escala piloto, com bons resultados, e terminamos agora com testes semi-operacionais no terreno. O objetivo final: produzir fertilizantes e corretivos a partir de subprodutos industriais, valorizando resíduos e promovendo uma agricultura e floresta mais sustentáveis.
Thank you very much.
Okay, apart from this small technical issue, we are keeping to the time. So, Paavo, it's a great challenge because two Portuguese people that really struggled to be on time, now a Finnish one is going to demonstrate that it's also possible. So, Paavo is coming from VALMET Technologies, he's the global product manager, and is going to tell us, or at least to demonstrate, because VALMET has done a study, how is it possible to be more efficient in terms of resources? So we are talking here about, of course, production sustainability, but also about lowering production costs, mainly energy, water, and raw materials, either on the short term, but also on the medium term. The floor is yours.
Boa tarde a todos. Como vai? So, thank you for the introduction, and I promise you I will keep the schedule. And you have been seeing a lot of great, excellent technical presentations during the past 3 years. So now it's finally the time for a less technical one. So please bear with me just a bit more. So, as introduced, my name is Paavo Hirvonen. I come from VALMET Finland. I'm the global product manager for our paper and board machine analysis services, and one big product group or theme in these services is this resource efficiency theme. So we're not talking about human resources, but energy, water, and raw material resources that we use in our paper and board production. So let's get going. Shortly about the agenda. So first, an overall view about resource efficiency in board and paper making. Then our framework, 4-step framework or approach to how we see resource efficiency development in board and paper making. Then a bit more details about this kind of resource efficiency study, which will benefit board and paper makers in reducing their energy, water, and raw material related costs. And then one example customer case from real life. Okay, so resource efficiency in board and paper making in general. So no matter where you stand in a paper or a board machine, whether you're on top of the building or down in the basement, every process section affects how resource efficiently you can run your machine line. So from the first pulper all the way to the wrapping up your finished product, you can always impact your resource efficiency, how well you are maintaining this raw materials, energy uses, and water consumption. And there are two sides of this coin, this resource efficiency. So first, the obvious one is improved sustainability. So that's one side of the coin. And the other is, of course, lower costs in your production, so saving money basically. And by reducing your energy, raw material, and water-related costs, you're of course improving your carbon footprint or reducing your carbon footprint, which then leads, like I said, to improved sustainability and cost efficiency. And then all major paper and board producers nowadays have their own publicly stated sustainability-related agendas and targets. And it's quite common in the industry to have, for example, ISO 14001 or ISO 15001 for energy or for environmental and energy management. So it's a common theme, mega trend, if you would say so. And these numbers here, these aren't exact because it depends where you are, how much you're paying for your energy, water and raw materials, how wide is your machine line and so on. But we're talking about big numbers what comes to energy, water and raw material usage in board and paper making. So you can well imagine that even small savings in these issues can bring you huge savings. Okay, then a pie diagram about electricity and steam consumption in a modern board and paper machine line, just to give you an idea about where we should focus first. So obviously to these biggest or bigger pie slices here, that would be our main focus if we would start from scratch. But like explained in the previous slide, there are huge impacts in terms of cost savings, even with little things. So we absolutely shouldn't ignore these smaller pie slices. Also, we have to be ready to include those also into our scope. Then, in board and paper making, like in basically all process industry, everything affects everything. So these resource savings are interdependent, like already in some other presentation yesterday, or at least in two separate presentations, we were talking about how saving water, for example, saves electricity costs, since you need to pump that water and you need to treat the wastewater after it has left the process. So there is additional costs related to the water, not just the water. But then in addition to these wastewater treatment and pumping costs, if you're wasting, for example, 5 kilograms per second of process water, which has been heated from, let's say, 20 degrees when it's coming to the mill, all the way up to 50 degrees centigrade, you're at the same time not just wasting water, but wasting a significant amount of steam if you need to heat that water with steam. And then, of course, you're losing water, wasting water, and like mentioned, pumping and wastewater treatment comes on top of that. And then, when we save raw materials, we're at the same time saving energy. So, for example, refining could be one option. If we don't reject as much raw materials out from our process, we don't have to refine as much. Fairly simple. If we're rejecting, for example, 3 tons per day in this consistency for 300 days per year, we're losing this much raw materials, which equals to this amount of money if we're paying on average for this raw material 400 euros per ton. And then if we are rejecting that raw material in 2% consistency, we're at the same time rejecting a significant amount of water. And again, if we need to heat up that water, we need to pump that water, and we need to treat it in our wastewater treatment plant. And then lastly, we shouldn't ignore our time and material efficiency improvements. So if we, for example, decrease our tail threading times 5 minutes for each tail threading we will have more production, and we will save money, and we will have lower specific resource consumption, since we are not generating as much broke as before, and we are using our resources to make the product for our consumers and not to dump it into our pulper, for example. Then our framework for this resource efficiency development. So few simple pictures. So first, benchmarking. Our first day pulp and paper market overlook emphasized us about knowing where we are. So this first step, benchmark, does exactly that same thing. So what is our situation currently, where we are in terms of resource efficiency performance? Then in the next step, we dive into more details. We figure out our operating window in which we hover around, for example, with different grades, different production speeds, and so on. So we get a full idea how we are performing in different production situations. And from there, we can narrow down the process sections in which we have more room for improvement than we do with the others. Then, in the third step, we implement those actions we have studied here. In the second step, we have generated an improvement plan, what we should do in order to make things better. And here, in the third step, we implement that plan, or we implement those actions into our current process setup. And then, in the last step, if we want to get the maximum performance out of our machine line, then in the long run, we need to make bigger rebuilds, invest in the latest, best available technologies to get the maximum performance out. So as you see, we start from one simple average figure, for example. We expand that to an operating window. Then we figure out what we should do in order to make things better. We implement the actions and move our operating window into more efficient direction. And then with last step, with investing, we get the best performance out of our machine line. Then about one possible way of studying what you should do in order to improve your resource efficiency in your paper or board making machine lines. So this is what these kind of studies usually include. Depending on where you currently stand, what is your current performance level, how much data you have from your own process. Do you know where you currently are, or do you not know? So usually it's a hybrid from the majority of these items here. So we can look things remotely, monitor them, optimize, give you suggestion what you should do, changing process parameters and so on. There are different measurements and analysis that can be done on site. Then, based on those, different process rebuild or modernization concepts can follow. And since this is a continuous cycle, we shouldn't follow that 4 steps, 1, 2, 3, 4, and stop there, but it's a continuous improvement cycle. So, of course, we should follow how our actions are affecting our performance, and then again, by the principles of continuous improvement, we need to continuously follow that cycle of figuring out where we are, what we should improve, and improve our performance. And then it's critical not to have just these investments, so telling everyone that, hey, you should buy a modern new press section in order to improve your dewatering and reduce your energy consumption, no. But to get also these low-hanging fruits into your table, which are easy actions we can complete immediately, doesn't take any resources, any money, can be completed immediately. Then smaller, medium-sized actions which then need some time, for example, some maintenance work, small process connection changes and so on. And then, like said, at the end of the day, also these investments need to be considered. And then providing these saving calculations, of course, for example, if we need to apply for an investment money, then these are extremely important. Then about the real-life example from quite a comprehensive study we have done. in Asia-Pacific area. So the target was to find resource efficiency improvement actions for these process sections listed here. And the solution was basically more or less following those 4 steps I showed you earlier. So benchmarking, knowing where the customer currently is, then performing the necessary studies, analysis, and measurements, then giving the customer the recommendations, what they should do, and then of course it's at the end of the day it's up for the customer whether they do them or not. But there were 6 specialists working on site, 2 remotely, over 500 pages in the final report, roughly 100 improvement actions, and roughly 1 million euros per year of identified savings. And now it's a good thing to remember that not every improvement action or recommendation can be handed over with a saving calculation. So for example, if there's some broken equipment and we recommend the customer that, hey, you should fix that broken equipment, it cannot necessarily be calculated how much energy they are saving, for example, by fixing that. And then a few examples about the savings we calculated there. So from stock preparation, over 3 tons per day worth of raw materials that could be saved, significant water saving possibilities, vacuum system fine-tuning, saving possibilities there, and then the biggest was this hood ventilation and heat recovery system upgrade that would generate these massive savings. Then summarizing really quickly. So, like mentioned, everything affects everything, and resource efficiency mindset is the way to go. So we shouldn't be focusing just on saving energy, but realizing that saving water equals to saving energy. So everything affects everything. Then about this 4-step framework: benchmark, quantify, optimize, and invest. So find out where you currently stand and take steps in order to improve your performance. And then these 3 different sizes of improvement actions. So easy ones, medium-sized ones, and then at the end of the day, also those investment recommendations need to be taken into account in the long run. And then one way is to have this kind of customizable study for your needs, for your current situation, and start building the improvement roadmap from there. Obrigado a todos. Thank you.
Thank you very much, Paavo. Thank you for trying to speak our language. It's also always a pleasure to the effort. I hope you are having a great time in Portugal, at least in terms of temperature, because hopefully the weather is better than in Finland.
Yeah, just changed my winter tires before coming here. So.
Okay, good to know. We don't use winter tires at all here in Portugal, maybe in the north of Portugal. So we still have 2 to 3 minutes. If there is any question from the audience, raise your hands. There is a question there. I think we will have a microphone. Okay.
I think you can hear me. So, thank you all for your presentations. I just have 2 small questions for the first presenter, to Fátima. I was just wondering, you showed me incredible results towards the reduction in the water vapor transmission rate and the oxygen transmission rate, but did you guys test something about the water contact angles and the COB absorption or not?
Hi. Actually, I did not present those results here today, but yes, we have tested, and so they were compatible with the results that we found by the other tests that we thought it could represent better the performance because we were interested in applications as food packaging and in applications where we might not have direct contact with liquid water. that's why I did not show. But yes, we have done that.
Oh, okay, thank you. And then my second question was about the migration tests that you said, of course, it's very important to do them. Normally they are done with food simulants. Did you guys plan to do actually tests with real food, like food extension life tests? If so, how do you guys are thinking about doing them? Thank you.
Yeah, that is a way to go, and we have started doing some screening tests to find what is the potential migrants. Right now, because this makes part of a whole set of studies that are being done in the scope of fossil to forest, we are particularly interested in migration of oligomers, and how the lignin inside the matrix can affect that. But yes, we start first with simulants, first screening, then simulants, and then food, and we are running some tests with foods that were selected based on the partners that are on the project. That goes from coffee, dry food, coffee and dry food, although coffee is also dry food, but it's a different type of food, okay? Yeah.
One more question, and we need to go to the next panel, okay?
I'm Inês. My question is also to the first presentation. And the paper that you used as some treatment, it's base paper, printing paper. What type of the paper that you use?
I'm so sorry, I'm not able to say, because now this paper was a new paper also developed under the scope of the project by Navigator. And it's not anything that is under secret, it's just that I don't remember the details now. But maybe someone in the room, like Joanna down, may address, because it's a paper also resulting from the project.
Okay, thank you.
A paper intended for packaging, yeah?
Yes, okay,
So sorry.
Okay, Paavo, Fátima, Ana, thank you very much for your presentations. A big thanks to the audience for having us, and we are going now to the next panel. Thank you.